am Dr. Neha Singh, Assistant Professor in CSC Department at Akgec Engineering College. Today we discuss the topic neural nets. So first we know what is a neural net. Neural net is also known as a neural network, and neural networks are a computational model inspired by the biological neural network in the human brain. Neural network is just working like the human brain, and human brain is also a complex structure. It has a many components like soma, dendroid, cell body, synaptic weights, so many components. So there are a type of machine learning that excels at the like image recognition, natural language processing for text classification, and many more. So these networks consist of interconnected nodes or neurons arranged in the layer, and they process the information through the weights, connection, and biases. Through the training, the network adjusts these weights to improve its performance and in slicing the pattern and making the prediction. So in neural networks is basically just like working on a human brains, and is associated with many nodes or neurons, and all these nodes or neuron are interconnected to each others. So neural networks are some key components like neurons, layer, connection, bias, and activation function. So neuron, also known as the nodes. So the neurons are the fundamental units of neural network, and they receive input, process them to produce the output. So and layers are organized into layers, and input layer receive initial data, hidden layer perform computations, and output layer provide the result. Now next component is a connection, which means weight. Each neurons and each node have some connection, some weight, and they and which determine the strength of the connections and influence how much neurons output affects onto and another neurons. Then biases, a value added to the weighted sum of input influencing the activation of a neuron. Now next is the activation function. So activation function is applied to the weighted sum to determine the neuron's output. So activation function is many types like sigmoid, Tanh, and many more. So how do neural networks learn? So in these three parameters are done: forward propagation, backward propagation, and iteration. So in a forward propagation, input data is fed into the network, and the signal travels through the layers with each neuron performing the calculation and passing the result to the next layer, which means each input layer is connected to the hidden layer, and hidden layer produce the output. So in a back propagation basically minimizing the weight of the the weight between the actual value and predicted value. So in back propagation, working on like output layer to hidden layer, and hidden layer to the input layer. So in the back propagation, the network compares its output to the desired output and calculates an error, and these error is then used to adjust the weight and biases of the connections networking backward through the network. In iteration phase, this cycle of the forward propagation and back propagation is repeated many times, with different training data gradually refining the network's ability to make accurate predictions. Now applications of the neural network. So neural network used in various fields like image recognition for using the identifying object, face, and senses in image. For in using natural language processing for understanding and generating the human language. Using in machine translation to translating the text from one language to the another language. For using fraud detection for identifying the fraudulent transaction, medical diagnosis, assisting in disease detection. Now financial forecasting, predicting stock prices and market trends. So now next topic is our deep versus shallow neural networks. So deep and shallow neural networks are different primarily in their architecture, especially the number of hidden layers. So in deep neural network, we use only one or two hidden layers, but in deep neural network, we use many hidden layers. So in Shallow neural network architectures typically have one or two hidden layers, and complexity of shallow neural network is simple, less computational expensive to train, and functionality of the shallow neural network suitable for simple tasks like linear regression, binary classification, or low dimension feature extractions. And also data requires generally is a train effectively. So in comparison to shallow neural network has three or more hidden layers, and complexity is a more complex architectural and more as compared to shallow neural network, deep neural network is expensive. So, and functionality of deep neural network is capable of learning hierarchical representation of data, enabling to handle complex tasks like image recognition, natural language processing, and face recognition, speech recognition. So data requirement of the deep neural network is a larger data set for effective training. So difference between shallow neural network and deep neural network. So number of layers in a shallow neural network is a one or two hidden layers. In deep neural networks, layers are three or more hidden layers. Shallow neural network complexity is simple as compared to deep neural network, and deep neural network complexity is a complex. In the computational cost of the shallow neural network is a lower, and deep neural network complexity is computational cost is higher as compared to the shallow neural network. And data requirements of the shallow neural network is lower, and deep neural network is a higher. Stability is a simpler task of shallow neural network, and complex stuff of deep neural network. So in a shallow neural networks with a few layers, usually one hidden layer. In deep neural with many layers, like multiple hidden layers. Complexity is low in shallow neural network. In deep neural, complexity is a high. Limited learning capacity in shallow neural network, and higher learning capacity in deep neural network. So, and shallow neural network lower risk of overfitting as compared deep neural network, and deep neural network higher risk of overfitting. Require less data in shallow neural network and requires larger data for deep neural network. Fewer parameters count in shallow neural network as compared to deep neural network, and many more parameters count in deep neural network as compared to the shallow neural network, and require less computational resources in shallow neural network, and require more computational resources like GPU, TPU in deep neural network. Easier to interpret, more difficult to interpret in deep neural network. So our next topic is a convolutional network. So convolutional neural network, also known as a CNN, or also known as a convolutional net, are a specialized type of artificial neural network, particularly well suited for processing data in a grid-like format, most notably images. So CNN also work. CNN is mostly CNN model mostly working on the images. They achieve this by employing convolutional layer, which use filter to extract features from the input data, and these features are then used for tasks like image classification, object detection, and many more. So CNN is basically used for the image detection, video and speech classifications. So in here this is the architecture of CNN network. Here take the input as a take the image as an input, and then perform the convolutional layers, and after that perform max pooling layer, then max pooling operation, then flatten operation, then fully connected layer, produce the output. So key components of convolutional layer is mainly four key components of convolutional layer. First is a convolutional layer. So these layer apply convolutional operations to input images using filters to detect features such as age, texture, and more complex patterns of the images. So convolutional operation helps and preserve the spatial relationship between the pixels. Now next components of the pooling layer. So pooling after the convolutional layer, pooling layer perform the spatial dimension of the input, and reducing the computational complexity of the number of parameters in the network. So max pool in a pooling layer, two operations is max pooling and mean pooling and average pooling. So max pooling is a common pooling operation using selecting the minimum value from the group of neighboring pixel. Then next layer is the activation functions. They introduce non-linearity to handle the allowing to learn the complex relationship in the data. Now next component is a fully connected layer. These are the responsible for making prediction based on the high level features learned by the previous layers, and they connected every neuron in one layer and every neuron in the next layer. how CNN works. So basically 5 steps, using the 5 steps to working on CNN. First, take the image as an input. So CNN receives an input image which is typically pre-processed to ensure size and format. Then detect the image width, height, texture, color. Now second layer is convolutional layer. Filters are applied to the input image to extract feature like age, texture and shape. After the convolutional layer, applying the pooling layer. The pooling layer generate the feature maps by the convolutional layer and downsample to reduce dimensionality. Then now next is a fully connected layer. So fully connected layer is in each node connected to each other, and the downsample feature map are passed through the fully connected layers to produce final output such as classification labels. And last is the output. The CNN output prediction such as the class of the images. So convolution, next is the convolution neural network training. So the training process of CNN involves the following steps. First is the data preparations. So the training images are processed to ensure that they are all in the same format and size. Then we use the loss functions. A loss function is used to measure how well the CNN is performing the training data, like calculating the predicted value and actual value answers. The loss function is typically calculated by taking the difference between the predicted labels and actual values of the training images. After that, we apply the optimizer. So optimizer is used to update the weight of the CNN in order to minimize the loss function. After that optimizer, we perform the operation is a back propagation. So back propagation minimize the error to calculating the actual weight and to calculating the difference between actual weight and predicted weight. Applications of CNN. CNN used in a various field like image classification for detection detecting the height, weight, texture and colors, and also used for the object detection to detect objects in images such as people, car and buildings. And they can also be used to localize objects in images, which means they can identify the location of object in the image. Also used in the image segmentation. So CNN can be used to segment the images, which means that they can identify labels of images, objects in image. And this is useful for applications such as medical imaging and robotics. And also used for video analysis. CNN used for analyzing the video, such as tracking the objects, events in a video. And this is this application is also useful for surveillance and traffic monitoring. Advantages of CNN. So CNN provides the high accuracy, state-of-the-art accuracy in various image recognitions, imagination tasks, and CNN are efficient, especially when implemented on GPU. And also CNN are the robust to noise and variations in the input data, and also adaptable. CNN are adaptable and can be adapted to different tasks by modifying their architecture. Disadvantages of CNN. First is the complexity. So CNN can be complex and difficult to train, especially for large data set. Resource intensive. CNN requires significant computational resources for training and deployment, and also a large need for the large requirement of data sets. And one of the main challenge, interpretability. CNN can be difficult to interpret, making it challenging to understand their predictions. So types of layer in CNN. So first layer is an input layer. So it's the layer in which we give the input to our model. In CNN, generally the input will be an image or a sequence of images. This layer hold the input image with the width 32, height 32, and depth is 3. So second layer is in CNN is a convolutional layer. So convolutional layer, which is used to extract the feature from input data sets. It applies set of learnable filters known as kernels to the input image. So the filters kernel are smaller matrices, usually 2x2 matrix, 3x3 matrix, or 5x5 matrices. So it strides over the input image data and computes the dot product between the kernel weight and corresponding input images patched. The output of this layer is referred as the feature map, and suppose we use a total number of 12 filters for this layer, we will give the output of dimensions 32 cross 32 into 12 dimensions. Next layer is CNN is activation layer. So by adding an activation function to the output for preceding layer, activation layer add the non-linearity like Tanh, ReLU functions to output of the convolutional layer. Some common activation functions like ReLU, Tanh, likely ReLU, etc. So the volume of remains unchanged, hence output volume will have dimension of 32 cross 32 into 12. So next layer is in CNN is a pooling layer. So this layer is a predominantly interested in the converts, and its main function is to reduce the size of volume, which makes the computational fast, reduce and memory, and also prevents overfitting. So in the pooling layer, two types of max pooling and average pooling. So if you use max pooling 2 cross 2 filter and stride is 2, so the resultant volume will be the dimensions 16 cross 16 into 12 dimensions. Next layer is a flattering layer. So the resulting feature maps are flattened into one dimension vector after the convolutional and pooling layer, so that can be passed into the complexity like for categorization or recognitions. Now next layer is a fully connected layer. So in the fully connected layer, each layer is connected, each nodes or layers are connected to each other, and this layer is a final classification or regression task. Now last layer of CNN is the output layer. So output layer from the fully connected layer is the feed into the logistics functions for classification tasks like Sigmoid or softmax functions, which convert the output of each class into the probability score of each class. Now our next topic is generative adversarial network. So generative adversarial network, also known as GANs, so are a class of machine learning framework, especially used for generative artificial intelligence. And in generative adversarial network, we use two types of neural networks like generator and discriminator. So generator is try to produce a realistic data like images or text, while discriminator tries to distinguish between the real images and fake images. Between real and generated. This adversarial process allows gens to learn to generate new data that closely resemble the training data. So in generative adversarial network, we use two components like generator and discriminators. So generator is used for creating the realistic images like images, video, images, text, audio, video, and discriminator is try to differentiate between the fake images and realistic images. So core concept of generative model is a types of generative model, meaning they are designed to generate new data instances. Now adversarial net training is the key innovations is that adversarial training process where the generator and discriminator are trained simultaneously. So generator is try to generate the realistic images or text, and discriminator is try to differentiate between the real data samples and fake samples. And zero-sum games is the two networks that are pitted against each other in the zero-sum game, where the generator success is the discriminator failure and vice versa. So how it works for the generative adversarial network? First, initial training, the generator starts by producing the random data. Discriminator evaluation, the discriminator is trained to distinguish between real and generated images or fake images. So generator improvement, the generator is then trained to produce data that fools the discriminator, making it harder to distinguish between the real and fake data or fake images. So iteration, this process repeats with both network constantly improving their performance. Now last is a convergence. Eventually the generators become good enough to produce the realistic data that the discriminator can barely differentiate from the real data. Application of generative adversarial network. So In generative adversarial network, many applications like image generation, creating realistic images of face, object, and senses, image editing, in image editing, modifying images such as coloring, black and white photos of realistic image resolution, data augmentation, generating synthetic data to train other machine learning model, art and design, generating unique artworks and design, video generation for creating realistic images, speech recognition, generate realistic speech text, and generating realistic text data. Now our next topic is semi-supervised learning. So semi-supervised learning is a machine learning model that combines labeled and unlabeled data for training the model, bridging the gap between supervised and unsupervised learning. So basically, semi-supervised learning is a combination of supervised and unsupervised learning model, and it's particularly useful when labeled data is scarce, but large amounts of unlabeled data are available. So this method is aims to improve the model accuracy and reduce the cost associated with manual labeling. So key concept of semi-supervised is labeled data, unlabeled data, hybrid approach, and reduce labeling cost. So labeled data points with predefined outputs or classification. Unlabeled data points without associated outputs or classification. And hybrid approach is SSL levers the both labeled and unlabeled data to train model, and reduce labeling cost, in which unlabeled data and SSL minimizes the need to from executive manual labeling, saving time and resources. How semi-supervised learning work? So first, initial training. A model initially trained on the labeled data set, and now exploiting unlabeled data set means incorporated into the training process. So various techniques are employed to leverage this data, such as self-training, graph-based method, co-training. So in self-training models, labels and unlabeled data itself, using its current prediction to refine the training set. And in graph mesh method, relationship between data points are represented a graph, allowing labels propagation from the labeled to unlabeled nodes. In a co-training, two models are trained independently, each using different subset features, different features that can help to other by labeling each other's unlabeled data. So in next is iterative refining. The model understands the data is continuously refined and is learned from both labeled and unlabeled data's example. So advantages of semi-supervised learning. Semi-supervised learning used for basically reduce manual labeling data, improved accuracy, and also used for cost effective, and it also is a versatile method. So example of semi-supervised learning: to identify the different types of flower with semi-supervised, you might use a small set of images like flower type that manually label rose, tulips, and flowers, and many more. Then you could use a much larger collection of the flower images, pictures found online, etc. So the model would use to label images, learns and the basics of feature of each flower type, then use the unlabeled images to refine it, understand the border of the range of variation within the each flower type. So classify the unlabeled data sets. That's all. Thank you.